All right, welcome to day 3 of the 2021 conference. Somebody's got to put that on mute. Um, Today we have more presentations on a variety of cartographic related topics, a panel on mapping the pandemic, and then we'll finish the day off with the Canadian Cartographic Association annual general meeting, which I hope everybody can stick around for. For the AGM, we will be using a Zoom link instead of the feed loop streaming system that we've been using. More details about this is included in the description box of the AGM session, which you can see at the break. And I believe the link isn't there yet, but Glenn will be adding the link soon, so keep an eye on that. I want to acknowledge our generous support that we've got from Maxar Technology, Clips Geomatics, Center of Geographic Sciences, and also Go Geomatics. And again, like before, if I encourage you to check out the sponsor information in the exhibit hall if you hadn't done so. Also browse through the various maps and posters in the online map gallery. As during the AGM, I believe we'll be handing out the map competition awards. And obviously a friendly reminder to presenters to enter the sessions early if you can before you're scheduled to go on, so you can test your connections, avoid any technical issues, and meet your moderator. Now I want to introduce our third keynote presenter of the conference, Dr. Steve Liang, a researcher, teacher, and a founder of SensorUp. He's a global influencer on the Internet of Things, is a working group chair for several international working groups of the Open Geospatial Consortium, and a professor and research chair at the University of Calgary. He's been recipient of numerous awards, including being recognized as one of Calgary's top 40 under 40. During his doctorate studies, he contributed to the development of GlobeView, which was one of the first virtual globe systems in the world, which was later commercialized and then acquired by Microsoft. Steve is an innovator when it comes to increasing productivity through the intelligent automation of geospatial and location data from virtually any source, Internet of Things. So on behalf of the Canadian Cartographic Association, I'd like to welcome Steve to the 2021 CCA online conference. We're very fortunate to have you join us here today, and we look forward to seeing what you have to share with us. And with that, you can share the screen and take over, Steve.
Thank you, Ted. Let me share my screen. And then, okay. Great.
And I'm going to turn my camera and mic off, but I'll be in the background if something happens and you need assistance.
Okay, great. So thank you all for having me. It's my honor to present one of my favorite topic, maps and IoT. And then hopefully this presentation will be useful for you. And then it's also, I try to share some of the thoughts I had during this, the past year. It was a tough year. It's a weird year. I don't know how about you. I've been in my bedroom for more than a year. It was a weird year. Anyways, okay, let's dive in. So my topic is empowering the workforce of the future with IoT and AI, and especially from a geospatial perspective. And then, so the first question is, who are these workforce of the future? Actually, I wear a COVID lens in this. It's like, what's the work, the future of work and the worker of the future after COVID? And how can we empower them to use IoT and AI? So yeah, that's hopefully this will interest you. A little bit about me. I'm a researcher, teacher, and entrepreneur. I'm a professor and at UCalgary, Geomatics Engineering, and Rogers IoT Research Chair. So thanks to Rogers for the support for my research program. So allow me to explore my curiosity, especially actually during this COVID time. So allow me to explore new research directions to see how can I help. I'm also a lab scientist for the Creative Destruction Lab, CDL. I don't know if you heard about CDL. CDL is amazing. It's really changed how we innovate in Canada, especially in academic setting, bring innovation into commercialization. And I also start my company, SensorUp. And yeah. So a little bit about SensorUp. So because you're going to see some work from SensorUp, we founded in 2011 and 2018. We raised our first financing from venture capital. So it's a it's a VC-backed geospatial startup headquartered in Calgary. And then we raised our previous round, the Series A, in 2020 during the COVID. It was an interesting experience. And then the customers include US DHS, NASA JPL, TC Energy, Husky Energy, Can Do Rail, Industrial Rail, and more. And the vision of my research as well as my company is as follows. So my research or the software from my company, which is the implementation of my research, is we want to be the fabric that interconnects the world's IoT data. So not just one data source, but all the different data sources, and empowering the connected workers of the future. So who are these people, especially during this time? Let me think about, okay, so we are the people. I mean, we are fortunate we can stay in, I'm fortunate I can stay in my bedroom and I can give a talk. It's part of my work. But there are people, the frontline workers, they have to be out there. They need to risk, right? Higher risk than us, right? So the workers in the oil patch, right? I read an article about the workers in the construction site. They worry about the COVID situation over there, but they cannot. They have to go there. They have to feed their family. So how can we combine different IoT data sources, including geospatial data, so we can empower these connected workers of the future, including both the desk worker and the deskless worker, the ones, especially during this time, they have to go out. And how can we apply, using IoT, empower them and apply intelligent automation? That means remove the boring and repetitive tasks so they can make higher level human judgment or decision making. And we can improve the whole situation, the productivity, the safety, the quality, and most importantly, make them feel happy, job satisfaction. And productivity is clear, safety is clear. What do we mean by quality? Quality means doing things first time right. How can we use IoT AI plus geospatial data so that they can do the first thing, when the first time they do this task, they'll do it right. Right? There's a quality. It's about job satisfaction. And that's my vision of my research as well as my company. So again, double click on this. It made me think about the COVID situation, made me think about what's the role of humans in the age of IoT and AI. Especially, COVID is accelerating the digital transformation process. And what will be different? I did this talk, I used this slide actually last year in December. So it was a number of the COVID situation. And then in Alberta, you can see actually the total case reached almost 90K. And we thought it was bad. And this is from yesterday. Right now we're more than 200K. So yeah, it just like, yeah, made me think about how can we help? How can I help with my research? With maps, right? How can I help? Right? Just if you can see the curve here, right? It's really about open and then we got very, very bad. And close, it get a bit better. I mean, the situation get better. And we open again and boom, it goes bad. Anyways. So there are a couple of ways to combat the COVID situation. So there is a medical way, right? The vaccine way. But there's the other way, actually, is a digital way. So I highly encourage you to look at this, to read this article. It's a year ago, actually, from MIT Technology Review. The management problem for COVID actually is caused by information gap. So what does that mean? Actually, we'll see a lot of situations or issues we have in order for us to make a decision. To open, to close. In the COVID situation, you say, when should we open? When should we close? Right? It's not only the government, it's also for a company, right? For the company. So what should they do to protect their employees, right? When should I close? When should I tighten to implement different restrictions, right? And the problem actually is information gap. Do they have the right information so that they can really make that decision? Because the decision about COVID, the pandemic, is quite simple or straightforward, is to reduce or minimize any contact to the virus. So if you have that information and to fill that information gap, and then you can really have a effective way to mitigate the risk and minimize the risk of COVID exposure. Okay. However, today, in not only COVID, I'm just using this as an example. A lot of organizations where they run their operation, they run the operation without this filling or addressing the information gap, the information necessary to help them to run the operation, right? Like, I don't know, in my university, for example, it's still I don't know, the case is still like every day I got email about cases, right? So if they have the information to make a decision, right? They know where to close, where to open, and when to open. Yeah, I think it's a risk can be minimized. So actually, at the end of the day, I think in GIS or geospatial society community, we know this very well. Is there are silos. Silos is one of the problem, one of the reason we have that information gap. Because do we have the information? In many cases, we do. But why do we still have information gap? Because these informations, they cannot be shared easily. We cannot combine them easily. So I don't know how about you. When the COVID hits, right? I just checked how many contact tracing systems out there. And I was like, wow, easily found 10, more than 10 contact tracing systems. So I was like, of course there's information gap because these systems do not talk to each other, right? If we push to extreme, right? Everybody, okay, that's forget about privacy or ethics, right? Let's say everybody carry a sensor. It exactly track where you are, right? And GPS tracker is so cheap, right? And then we can really address that information gap. But when you have so many different systems, right? Alberta have a different system than federal, right? And these contact tracing systems are useless because instead of you address the problem of information gap, actually you create information gap by having different silos, right? And this is not new to us, this community, because 30 years ago, it was GIS. GIS was like that. There are more than 30 different GIS data models and data formats. Right? And today, thanks to OGC, for example, and then we can freely exchange the information, right? Because we have these, simple feature geometry models. We have, the query languages. We have OGC APIs, GeoJSONs, so we can exchange information, right? So, but this, this situation or the problem exists in many different places. So. The next one is IoT Asylum, so what? I think I kind of explained, silo, so what, right? The silo is bad because it gives you, the information gap, so cannot make a decision. Let me give you an example. So in a lot of situations, actually they have this problem with a symptom when they have a, different silo systems. For example, this is a screen capture of one of our customers. This is a person, he or she needs to look at 7 different screens and get data from 4 or 5 different systems. So the goal is very simple, actually. Make sure there is a truck, go to a place to pick up the wastewater before the tank is full, and then dispatch the truck to a place and you can dispose the wastewater and cheaply and safely and without minimum weight. Do they have the information to make a decision? Yes, they do. Because they put a whole bunch of sensors, the GPS tracker, the fleet management system. They have the facility data, where the wells are. Okay, but however, can they automate it? They cannot because they are in different systems. So at the end, the person is using Excel and watching 2,000 wells every day and try to make sure that they cannot miss it. Because if you miss, you cannot let the tank to be full, right? It's not easy to stop the production. So as a result, actually, it's the person is sitting in front of so many screens and then looking at different systems, manually correlate the data, and then a lot of phone calls and radio calls. And then all these radio calls and phone calls are not captured. That means it becomes that person's own knowledge so that the whole process cannot be easily improved because that knowledge or the whole process, the tasks, the result are not captured. Okay, and then hopefully you will see this. You recognize this in a lot of operations, right? Let's say first responders. Let's say it's saving lives, right? If it's water, liquid Holland, it could be waste, how to move the waste, right? And it could be, for example, methane detection and leak detection and repair, right? You all see this, right? Herding the cats happening in those, right? And the problem is multiple data silos, no real-time visibility, no early warnings, no automation, complicated process, radio communication, ad hoc communication, and human errors. Exactly the same thing in the COVID situation. So that's your homework, 2 books. I will encourage you to read, actually 1 paper, 1 book, right? So one is Prediction Machines. It talks about what's AI and what's a human's role in AI. I'm just let you know, I really like this book. It's on my desk. And the other one is a Harvard Business Review about how smart connected products are transforming competition. So on the left-hand side, it's the Prediction Machines about AI. On the right-hand side, it's about IoT. Okay, so let's decipher this. What is AI? So I want to use a different language. It's let's not talk about algorithms, not talk about different clustering, what's enforcement learning or deep learning, right? We'll talk about AI, something we can understand. I mean, without talking about the algorithm. So I want to replace in the future, replace AI, replace with predictions. So AI basically is predictions, right? It tells you something that you do have and generate information you don't have. Right? So for example, let's say AI, it was a very difficult task in the past. Let's say you have a picture and try to count how many sheep in that picture. It was very difficult for AI at the time because first one is to find the sheep, right? So it's a classification. Oh, detect objects and classify the sheep or dog or cat, right? But for humans, very easy. But from that example, right? So to have a paper, have a picture, and counting how many sheep, right? So taking information you do have. So what information you do have in that case is the pixels. The pixels are the information you have. Okay, generate information you don't have is how many sheep in that picture. Okay, and that's a prediction because when you count, even for a human, when you count the picture, right, how many sheep in that picture? I don't know. That's a sheep or it's a cat, right? It's a very big cat. Okay, so it's when you count as a human, it's also actually a prediction task, right? You have your confidence level. Okay, so AI basically is prediction. Taking information you do have and generate information you do not have. And today, what's new? I remember actually at the time I was a grad student, when I run some data mining tasks, it took a night. And hopefully the computer doesn't crash. There's no memory problem, right? And then so I can see some results. But today is not. Today the chips, the chips, right? Computing chips are so powerful and affordable. So AI become affordable. So I want to replace in the future AI is like whenever you see AI, replace it with affordable predictions. And when you have affordable things, what do you do about it? Right? I don't know how about you. I mean, when I have a roll of duct tape, right? I use it for everything, right? It's redneck engineering. I'm in Alberta, right? Redneck engineering. So when I have a duct tape, right, I use it for everything. It's affordable, right? It's just readily there. So when you have affordable predictions, right, AI, and you start to use this AI in many different places and to give predictions. And this is really changing the world, okay? And then, for example, some prediction. I think I just, the last point here, right? So actually classification is a prediction, right? So when you look at a medical image, there's a tumor, right? It said, okay, identify a tumor. Is it good or bad? And then what's the confidence level? That's a prediction as well. But it's just like a human. A radiologist do that as well. It's a prediction. Okay. So this is something called the AI canvas, and I just did a little bit change to IoT and put IoT. So this is a very good framework, allow you to look at in any operation, you break down the operation into workflows, and workflows are consisting of the tasks, and each task you can fit into this AI canvas and see, okay, is this a prediction task? If this is a prediction task, how can I use AI to do this, right? So for example, if you have an IoT, right, the inputs, right, when you need the input to feed into the AI, so input is sensing, it's basically sensors, right? And you make a prediction, and from the prediction, and you present that prediction to a human and to make a judgment. A judgment, what do we mean by judgment? The judgment is the risk of not doing it. Okay, so when you make a decision, you always have the risk or the consequence. Okay, the human judgment is the risk of not doing it. When you have a prediction about that tumor is a bad tumor, and then I have a 61% confidence level for that from that AI model, and still you need a human to make that judgment. It's like, what should I do about it? Do nothing or do something? Okay, so human make that judgment. So that's why I'm talking about how to use AI and IoT. IoT give you the inputs, the AI give you the prediction, and we can remove the repetitive tasks so that the human can make a judgment, do or not do it. It could be a firefighter, it could be an oil and gas worker, it could be a construction worker, and could be a desk worker as well. Or the desk worker working with the deskless worker to make that judgment. And then once you have judgment, you have action. The action basically are tasks, right? There's a task and somebody to perform that task. And after you perform that task, and you have outcome. Works, doesn't work. And this outcome needs to be captured and to AI model into learning and then make your prediction better. Okay, so imagine, so think about the example I just showed you, right? About the liquid hauling, right? The person herding the cats sitting in front of many screens and manually correlate the data and try to make a good decision. So that's a lot of manual work. But with AI, what we can do, the inputs are the different systems, right? The SCADA system are the water level, the location of the tanks, location of the terminals, you can dispose water, and the wait time for the terminals, and where the trucks are. Okay, and then you get all this. Oh, how do you get those information? From sensors, GPS sensors, the SCADA systems for tank level, so on and so forth. And then you feed into AI. Today it's done by a person. Try to see, okay, this tank is full. Okay, here's a truck. Okay, how can I put them together? So the AI present the prediction. Okay, here's my assignment. I assign the following trucks to the following water tanks, and because I run my, for example, sales, travel salesman's algorithm, this and that, and then the operational research stuff, and then I match them. So here's my recommendation about you should dispatch the following truck to these tanks. And the human can make a judgment. It's like, okay, I agree with this plan with my experience. I don't agree. I change the plan a little bit, and then push the task to the trucks. And the trucks go there and haul the liquid out, and you have outcome, which is the distance traveled, the money you paid, or late, early, this and that. And then all these will be captured into learning and make the next prediction better. But today, it was not captured because this is very ad hoc. A lot of radio calls, right? And then they don't track the outcome in a fine granularity, right? So this is just one example to show, okay, for that task, which is dispatch the truck to haul the liquid out, okay? And then how can we use AI to make that prediction so the human can make a judgment? And then, so higher level task. So this is one example. And this framework can be applied in many, many different places. Hopefully this is useful for you. If we are in the same room, I'm going to ask you questions, but I cannot ask questions here. But so I assume it's useful for you. But so what, right? I remember actually I read a book called Art of Start, right? He said, just imagine you have a small, you have a person, right, sitting on your shoulder, and you always ask the question, it's like, so what? So what? Whenever it says something, it's like, so what? Okay, so really, what's the, so what, right? What's the power of AI? So what? We replace this task, so what? Okay, so just imagine you have a dial. You can really crank it up. The power, your dial for the power of AI or the accuracy of AI, you can crank it up. Let's see what's going to happen. So what if the AI becomes so very accurate, right? And that's really, really, the previous example is I make things more efficient, right? But in some cases, when you crank it up enough, you totally change the way we operate things. You totally change. You have a disruption. So that's user example. In this situation, we all know, which is Amazon. I don't know. I want to ask you, raise your hands, right? So do we have anyone don't use Amazon in the past year? I don't think that will be the case, right? I don't know. Every day there's something, it worries me to hear the doorbell, right? It's like, oh, what did my wife just buy? Okay, every day is like, ding, and I see, okay, What's from Amazon? So what does Amazon do? Amazon, they do online shopping and they recommend products to you. Okay, so today when you do shopping, right? So what's your online shopping workflow, right? The workflow is you shop online and they ship it to you and then you receive it and you can choose to return or not. So that's the workflow. And Amazon has this recommendation engine, right? It's a AI, it's called collaborative filtering. And then like Netflix, right? Recommend you one movie you should watch, a show you should watch. And in Amazon, they recommend you what you should buy. It might interest you, right? So how accurate is that recommendation engine for you? I want to ask you this question, right? So when I say how accurate, it means when they promote 10 things to you, how many are you going to buy? I think it's different. And for me, it is maybe 1 or 2, right? The 10 items, maybe I won't buy 1 or 2 when the things they recommend to me. I remember actually, especially when I have a new baby, right? The baby actually, whenever they recommend me, it's like, whoa, this is nice, I'll buy it, right? It's more accurate. But for now, it's like 1 or 2 things, maybe. But that's crank it up. What if Amazon's accuracy, the recommendation or prediction about what are you going to buy is so very accurate, but it's not 100% accuracy. It's about 60% or 70% accuracy. What's going to happen? They can really change the workflow in a very disruptive way. They can change the workflow from shop, ship, receive into ship, receive, and shop. What does that mean? That means because they can recommend, they can predict what they're going to buy. So before you even buy, they ship it to you. So every day you open the door, it's like, oh, there are Amazon daily recommendation at my doorstep, right? I'm going to keep these 6 stuff, right? Because I happen to need the toilet paper. I need this. I need that moisturizer. And then I'll return the rest of the 4. So it becomes ship, and you receive it, and then you shop every day at doorstep, right? The lettuce or whatever from the Whole Foods, this and right? What's going to happen in that case? So because the prediction, if it doesn't have to be super accurate, right? It just needs to be accurate enough so that the cost of return, right? When you shop, that means you might return some things you don't buy, become low. And they can centralize, make the return very, very efficient, okay? So the ship, receive, shop. What's going to happen? When this happens, do you think you still need to go to Costco or Walmart to buy anything? No, you don't, because you shop at your doorstep. So you totally wipe out any competition because there's no chance for Amazon's competitor to get into this workflow because it's ship, receive, and shop. Okay, so this is a disruption. It's a dynamic change. And this is what IoT and AI is going to change to the world. Is we don't need to be very accurate, just to be accurate enough, and then it will totally change the way we operate, the way we compete, including university actually. So of course, Amazon has a file patent on this, right? It's called anticipatory shipping, right? To start sending you stuff before you have bought it, right? And this is going to happen. But that's pushed to the extreme, right? That's Amazon, right? But how about in our world? So, I typically do that, right? I learn something from the book and this and that, and I try to apply into my world. Okay, so what kind of AI or not AI, predictions, what of a task that require predictions, and then we can use AI to replace the human predictions? And what if it becomes so very accurate? Okay, what kind of dynamic shift is going to happen? And then it also made me think about what is cartography's role in the age of IoT and AI? Can we play a role in this? How can maps play a role? And in my opinion, I love geomatics. I love this because I think geospatial is everywhere. Because literally everywhere, where, right? So I believe there's a role to play, actually. Hopefully I can show you an example. And cartography is the art and science of making it using maps. So, okay. So go back to this AI model, right? The canvas, right? We have predictions. And predictions, actually, you know what? How do we communicate the predictions to the human judgment. Map is a powerful way to do it because it's really about how to condense, generalize, abstract information, tons of information, and so that the humans can make judgment, can make decisions. That's cartography, right? So how to do this? So in my opinion, actually, we still play a big role in the whole AI revolution right now. So how to represent the sensor information from multiple systems and then on a map so that the human can make a decision effectively. Because when you present everything, we know actually we cannot put everything on the same map, right, for cartography. Okay, so how can we do that? So map still play a critical role. How to filter information for the predictions, the sensing, and the tasking, so that we can make a better judgment and right? So I think that's something I think very, very we can contribute to the whole situation here. So of course, when I have a question, I always go to movies to find answer. And then so actually, what's the future of map with IoT and AI? Harry Potter has an answer, right? The map. So I'll show you a video. Let's see if I can find it. Okay, I'll play the video.
No good. Messrs. Mooney, Wormtail, Padfoot and Prongs are proud to present the Marauder's map. We have so much. Hang on. This is Hogwarts. And that, no. Is that really Dumbledore? He studied pacing. Does that a lot.
Okay, this is very important here. This is an IoT and AI empowered map, right? And then you have the tracker for everybody, and then the map also changes the context, right? And filter information you don't need to. And also it says something. It tells you not only location, but also the person, so identification of the person, but also what the person is doing, okay? The activity. So that's the future of map. That's Harry Potter explaining all. What they are doing every minute.
Okay, brilliant. Where'd you get it? Nicked it from Filch's office.
Okay, so that's the future of map with IoT and AI. And then, yeah, hopefully that's, just make the presentation more interesting. Okay, so let's push a little bit to extreme. Huh? So with this IoT and AI and geospatial information, what are the disruptions going to happen? How about this? Use our example I just gave you, right? The liquid Holland. What if today is somebody coordinate this and dispatch a truck, make a phone call and to a trucking company, can you dispatch this truck to that tank and then haul it out and then send me a bill? But what if the trucks arrive before a service request even happen? So instead of even need a person to there to coordinate this, how about the truck arrive at the tank and then send a message to the coordinator? It's like, I know your tank is going to be full and I'm here and I'm going to give you 20% discount if you let me to haul the liquid. That's usually example actually we might know better is what if when you, let's say you want to go to an airport, right? Fly to Caribbean. We all dream right now, dream of last night, right? I want to fly to Cuba. No, I want to fly back to Taiwan to eat my Din Tai Fung. But I cannot. But what if because the Uber predict they are going to go to airport. And the Uber said, Mr., Mrs., and then I know you're going to need to go to the airport, right? If you use me, and then I'll give you 20% discount. Do you think you'll even call Lyft or taxi company to do that? You don't, right? Just exactly that shopping example. What if you have combined all the geospatial information, real-time historical for training, plus the vital signs, the condition, environmental monitoring conditions, the toxical plume, this and that for firefighters. And then you can have a digital assistant. Warn the firefighters before flashover or even before any accident is going to happen. right? And the digital assistant talk to the firefighter. It's like, run, left, right. It's a prediction. And do you think we can totally remove any safety incidents? Possible, as long as your AI is accurate enough. How about dispatch or inspection repair? There's a methane leak detection. Like methane leaking is a big topic right now, right? Because methane is a very bad gas, very hot. What if you stop the leaks before they even happen? So dispatch, inspection, repair before your equipment fails. So your equipment will never fail. Your leaks will never happen. And how to do that? Using AI, IoT, plus geospatial. So let's revisit, right? Our vision is really the fabric interconnects towards IoT data so that we can inject into the AI and then make predictions, because predictions need data. And the data will, most of data, a lot of data will be from the sensor data. And if you look at actually into our workflow for cartography, right? Or geomatics, right? So where do we get data? Sensors. Sensors are not new to us, right? Total stations or LiDAR sensor, the SAR sensor, sensors, yeah? So sensor, it makes predictions. We can empower the connected worker of the future. So desk workers and deskless workers, the Uber drivers or the coordinator, the truck drivers, as well as the logistic coordinator, right? So empower them to work seamlessly together and capture the information through the whole process, and then apply automation so that it will be safe, productive, good quality, and job satisfaction. So here are my bold predictions. In the future, near future, everything will be sensored up. That means every object will have sensors, right? I don't know. How many of you have the AirTag? You bought the AirTag, right? $25 each. And then I think the cheapest product from Apple, right? A dongle is more expensive than AirTag, right? So the AirTag. So everything will be sensored up. So the AirTag is $25. You can attach to an object and then track the location, right? So it's really coming. Everything will be tracked. So actually, I lost my wallet. I couldn't find wallet yesterday. So I just told my wife, I'm gonna get an AirTag so I can find my wallet every day. I don't even know why do I need a wallet. I'm not going anywhere. Anyways, everything can be sensored up, becoming smart objects and offering unprecedented visibility in automation. So that means we know everything, the locations, and then the conditions of everything. That's gonna happen. I'm going to show you a video about the work we've done, and then we believe how can we use sensors in IoT and the IoT and AI plus geospatial information to address the information gap so we can fight COVID. Hi, my name is Steve. I'm the founder and CTO of SensorUp. In this video, I'm going to show you the COVID module we configured based on our SaaS product. Our COVID solution has two parts. The first part is a digital map showing real-time and historical activities and risk levels of workforces and workplaces. SensorUp is sensor agnostic, and we can aggregate data from disparate contact tracing sensors, social distancing sensors, cleaning activity reports, locations of health supplies, etc. With the live and playback maps as the single pane of glass, decision makers can plan, track, and respond to emergent situations. But not everybody has the time to sit 24/7 in front of the screen. The second part of our COVID solution is a workflow engine allowing decision makers to automate workflows by assembling real-time tracking, sensing, and AI-based predictions and trigger events. In this demo, we aggregate 6 disparate IoT systems, including 4 different contact tracing beacons, video cameras with deep learning AI, and video plus microphones for cough detection. Here, we integrate an AI-based virtual sensor developed by the University of Calgary. It is able to sense how many people in the room, detect coughing based on video and sound, and even detect the event when the person who just coughed touched the door handle. Now, you are looking at the real-time digital map of the meeting room we just showed you in the previous video. As the people entering the room, you can see the risk level of the space is going up.
we can configure different ways to communicate visually the risk level of the space. For example, each room has a capacity limitation. In this demo, when the number of people exceeds the capacity limit, the space, and when the person who just coughed touched the door handle, the risk level of the room goes even higher, and then the cleaning crew will be notified. And after the cleaning crew disinfects the space, the color of the 3D space turns back to green. All these events and sensor data are captured and stored and can be used for improving the effectiveness and efficiency in the future.
My next prediction is with IoT and AI, every process will be just in time. That means there's no wait and no waste. So just think about that, Uber arrived before you need to leave and just here you go, right? There's with the AI, IoT and AI, there's no more wait and no more waste. I will show you an example about just-in-time liquid hauling solution.
Hi, my name is Steve. I'm the founder and CTO of SensorUp. In this video, I'm going to show you the SensorUp liquid hauling solution based on our SaaS product. Liquid hauling is one of the largest operational expenses for oil and gas companies. However, the operators today do not have the necessary real-time data and AI predictions to make optimal decisions. Our liquid hauling solution has two parts. The first part is a digital map showing real-time historical and even future tank levels, fleet activities, and all wait times. SensorUp is sensor agnostic, and we can aggregate data from disparate sensor systems with the live and playback map. As a single pane of glass, operators can plan and track fluid hauling activities and receive early warnings before delays happen. But no one has the time to sit in front of the screen 24/7. The second part of our fluid hauling solution is an AI-powered workflow engine, allowing operators to automate repetitive tasks and workflows by assembling real-time sensing, tracking, routing, AI-based predictions, and trigger events. In this demo, we aggregate disparate SCADA systems, tank-level predictions, fleet management systems, truck tank sensors, terminal wait time predictions, and travel conditions. With SensorUp, an operator can see a map that predicts where and when the tanks are going to be full and require a tank truck. The operator can also access a real-time map showing the terminal locations with their current and future wait time, their rates, and capacities. By combining these disparate real-time data sources and predictions, we empower the operator to make optimal decisions that minimize the trucking cost, wait time cost, and disposal costs. Once the truck has been ordered, the operator can also access the real-time locations and activities of the liquid transport. Before exceptions, such as longer than expected dwell-ins, are going to happen, early warnings will be sent to the operator for mitigation.
My last one is about safety, and especially, there are some COVID outbreaks in Taiwan right now. They're doing very well, but not in the past week. I saw news items like some people, they are quarantined live by themselves in a room, and the next day when somebody opened the door, and then the person just died alone, and it's really sad. It made my mom very sad when I talked to her, and then I'm like, yeah, in the future, right? All preventable safety incidents need to be predicted and mitigated before they happen, or at least we shouldn't let a person die alone in a room, right? And then we can do better than that. But just unfortunately, this happened so often last year, everywhere in the world. So yeah, with IoT and AI, if they have a vital sign sensors, and then at least we will not let them die alone. So I'll show you an example about IoT-enabled public safety solutions, our contribution, how to solve the problem.
Hi, my name is Steve. I'm the founder and CTO of SensorUp. In this video, I'm going to show you our situational awareness solution based on our SaaS product. In a situation where every second counts, every decision could mean life or death, it's critical to understand where your responders are and what situation they are in so that they are fully protected, fully connected, and fully aware. SensorUp is sensor agnostic. We can aggregate real-time data from disparate sensors, including wearables, location trackers, environmental sensors, or even drone. With the live digital map as a single pane of glass, a real-time common operating picture can be established and shared so that decision makers can receive early warnings and make accurate and informed decisions. In this demo, we connected to more than 20 different sensing systems, including heart rate, indoor location, outdoor location, fall detection, body temperature, chemical gas, ambient temperature, and more. In crisis, nobody has the time to combine high-velocity data from multiple screens. With SensorUp, decision makers are only alerted when there's an issue or a crew member needs assistance. This allows them to focus on making the decision that matters the most. SensorUp's AI and stream processing engine is able to predict risky situations before they happen, so that actions can be taken in order to mitigate the danger. After the event, all the sensor data are captured, can be reviewed at the hot wash, feed back into SensorUp's AI engine, and make it faster and better. First responder agencies also use SensorUp to protect first responders over the long term. Our solution can build a long-term health picture throughout the career of each team member with data from different stressors, heat and gas exposure levels, and injuries. In summary, by combining disparate sensor inputs with AI, we are able to establish a common operating picture, showing real-time activities and predict emergent issues. SensorUp also built a long-term health picture to protect team members. To learn more, please visit sensorup.com.
Hopefully these 3 demos show you a glimpse about when we have more sensors in AI predictions, better predictions, and then what can be achieved. And then the goal is not just to automate or remove some redundant tasks, but it's really about provide that dynamic shift and totally change the way we run operations. This is the last slide. So number 1, human is always the center of mapping. When we make maps, right? For example, the demos I show you, they are maps, and they are discomposed real time, and then by the workflow engine, and filter information, abstract that, generalize that, and push in real time to decision maker to make judgment. Humans still the center of computing and mapping. AI and IoT and AI makes predictions so that we can make judgment. And organizations can replace repetitive predictions with AI. Empower humans to make judgment and will survive and thrive. And then maps empowered by AI IoT, hopefully I show you a glimpse, and then will significantly improve quality, productivity, safety, and job satisfaction. And we play a critical role. How to aggregate, filter, abstract, generalize data and predictions so that we can make a more effective decision. And that's what I've been doing in cartography in the past hundreds of years. And hopefully today's information is useful, and then, or at least entertaining. You get to watch 20 seconds of Harry Potter. Okay, thank you very much. And then do we have time for questions?
Thanks, Steve. That was really interesting. So yes, I'm watching the chat in case anybody has questions that they would like to ask. Go ahead and enter them. In the meantime, while I wait to see if something shows up in the chat, I guess I can ask you one question, because one question that occurred to me a couple times through your talk was the whole issue of AI and data quality. And maybe you can just expand on that aspect a little bit, because you're talking about predictions, but the predictions are based on the data that's being fed into those predictions. So how much pruning and cleaning and massaging do you find you have to do to actually get reasonable predictions out of the different pockets of data that are coming from everywhere right now?
80% of the time? Yeah, actually, it's a great question. It's if you look at AI workflow, right? So you spend most of the time in, cleaning the data, get the data ready to be AI ready, right? And then, so think about any workflow, right? I want to encourage you to think about workflow, right? When we do surveying, right, mapping, you get the data from total stations and very noisy, so you design your network to be strong and robust, and then you can run your least square adjustment, and then this and that. To clean that data, at the end become map, okay? So still, it's a lot of time is about data cleaning, accuracy, precision, this and that, right? So this is really a lot of time is to make sure the data quality is good. However, okay, we can apply AI into the data collection or into data quality, identify outlier, for example, right? Clustering, right? So it's an outlier, right? Apply automatically. So actually, again, encourage you to think about the workflow, and then data cleaning is part of the workflow, and there's a task actually can be done with AI. So use AI to help AI.
Yeah, that makes a lot of sense. I mean, in teaching my students also, they come back to me after they get a summer co-op position and they say, I didn't really do any GIS. I did a lot of data cleaning. so yeah, I can believe that.
It's applied to AI scientists, right? Data scientists, right? So it's just a fancy name for data scientists is a fancy name, but actually 80% of the time they are doing data application and cleaning.
That's right. So Roger Wheat asked a question. Do you integrate your dynamic mapping SensorUp developments into basic teaching in things like in courses like introductory GIS?
Not yet. Not yet. Again, it's quite an advanced topic, like you said, right? So cleaning, real-time data communication protocols, scalability, cloud. So I do integrate that into my teaching in the 4th year class and the 1st year master and PhD student class, and also the capstone projects. They use what we do to do their project, but not in the the basic one. But we'll definitely see it's gonna it become more easy to use, and then become more in the 1st year class or 2nd year class for sure in the future.
Okay, very cool. Mark Kumler has put a question in the chat, which is a really good question. So you've made some predictions through your talk today. And so Mark's question is kind of along the lines of, so how do we turn those predictions into some reality? So what do you think we as a society need to do to start making some of these ideas a reality?
I think it's happening. If you are using Amazon, right, the AI is there all the time. When you watch Netflix, the collaborative filtering, right, the recommendation is there all the time. And then when there are a lot of AI for predict maintenance, right, to predict the machine will fail or not. So it's really happening. But I would say the issue right now is happening in silos. So we try to push into for me, it's when you have a AI to remove some repetitive tasks, that's great. But those are just incremental, right? It's not a disruption. And what I'm looking for, and it hasn't been a reality, is the disruption. And I think for everybody to really watch out for this disruption, because, for example, like if Amazon can predict that accuracy about what people are going to buy, and then Walmart is in big trouble, right? And so every organization, the C-suite, need to think about it. Okay, what are these threats and will endanger my existence? That's interesting for me, and it's not happening.
Yeah, if I could maybe push on that question a little bit more from a slightly different perspective, which is in the business world that's happening. But one of your examples earlier was, sorry, just a sec here. One of your questions earlier was that, sorry, I lost my train of thought here. One of your examples earlier was talking about things like the silos for COVID, and things like OGC, standardized formats, things like that. They break down sort of the flow blockages of silos, but they don't necessarily break down the semantic impedance to those silos. So things like politics, the fact that Alberta insisted on having their own COVID tracker tracing technologies. In the political world, how do you actually see some of this being moved forward?
That's a big question. I'm a techie, so I tend to look at it from a technology perspective. But unfortunately, people build walls. That's what we do. And then again, I'm going to answer the question from a technical perspective, right? I think right now, the average citizens, right, we are empowered, right? And we have this, democratization of data, right, like open data. And it's a weapon allow us to really push these institutional problems. And actually, if you look at interoperability, right, you have the syntactic, and you have semantic, and you have the institutional. And actually, what you talk about is the institutional. If the organization, they don't want to share, what can we do about it? So one thing we can really push is, to push a open source system or a crowdsourcing system, so that to force them, not force them, to show them what can be done, right? And we see some examples, right? So we have a project supported by NRCan for air quality systems, right? So we empower citizens to deploy IoT sensors to collect air quality, crowdsourcing. And then, so we really push the data transparency. And there's a, ground up grassroots system with all the data they are sharing. Okay, so we will join them to share. Right? We see that in many cases, right? OpenStreetMap is a good example. And to think about what can we do, right? With what I can do with my expertise and experience. That's one solution, or not solution, a way to look at this. Not a very good answer, but sorry.
No, thank you. That it is a big question, but it's also one that I think we critically need to figure out an answer to if we are going to see some stuff move ahead. Fox Underwood asked a question about, so the SensorUp PM 2.5 maps have gone down recently. Are you replacing it with a different type of map?
What we can talk offline. There's so number one, the project ends, right? So we don't have funding to support that, to operate that anymore. And then we're looking into options right now. We do want to keep that. And and also we show the example, and there are other organizations, they pick up the effort. So we'll bridge those sensors into those, more sustainable models. Sustainability is very important.
Okay. Zenon Zikowski, hope I pronounced that right, said, I have a more philosophical question. Do you think that the more predictable the world we are creating, the less interesting it is becoming, putting aside all the interesting technical aspects of your incredible work? But do you think better predictions, do they make the world less interesting?
No, I think when we have better predictions, right, it just makes the world more interesting, because we can focus on things that are today we cannot focus on right now, right? So for example, today when you have Google Map, right, you can predict your estimation in the ETA, right, estimated arrival time. It just makes your life even better. You can do other things, right, more efficiently. And then you need more predictions for other things rather than be late or, don't know when should I start, right? So actually I was in a panel, I was listening to a panel, right? And then they said, okay, with the AI and IoT, right? And actually people, they make, that's a VC, venture capital, one of the most well-known venture capitalists in the world, in Silicon Valley. And he said, actually, with all the predictions we have, and then we have no job. And one of the government's purpose is to create jobs for the community, for the society today, right? So top one, reason they exist is to create jobs, right? So we can maintain the whole society. That works, right? But with AI and IoT, we have no more jobs to do. So government's job will become create purposes for people. So they don't work on job, so trade time for money. They work on the things they like, and government will need to create purpose for people. I found that's very interesting. Of course, a little bit, futuristic.
Yeah, that's pretty idealistic as well.
Unlimited computing power, right?
Yeah.
Everything.
Yeah, no, I think there's an interesting discussion there that you could probably spend a fair amount of time on, just in terms of, is that a world without serendipity? But I think people are always going to introduce all kinds of serendipity and unpredictability into these things anyways, would be my guess.
Exactly.
Fiona Gregory had a question, which is, are any workplaces currently using your tech for assessing risk like you showed in the videos?
Not the COVID. The COVID actually is, if you mean the COVID, we published 3 papers actually, and it's an open architecture, and then but it's not implemented in the in any setting. But we actively talk to NRC, Health Canada, this and that, right? But right now, vaccine is the solution to go. But for safety purposes, right? First responders, right? For example, work with the Vancouver Fire, so they are using it. DHS are using it. In certain more on the capacity, but also we work with some large complex physical operations like oil and gas and mining. They are using it.
Okay, very interesting. Christopher Lee has put a question in the chat. Will AI be able to design maps and make decisions on how to analyze specific geographic phenomenon? Example, using appropriate colors, symbols, analyzing techniques, and tools to depict the map. So how far do you see AI getting in terms of offloading the mundanity of trying to make sure that you're treating the data right and representing it right and doing some of that decision making for you, as opposed to the current GIS defaults that we all basically teach our students to, never use the defaults.
It's happening. So for example, like the example I show you in SensorUp, right? It's using some workflow engine AI predictions to make map. So basically, but it's basically, right? How do we communicate the color or danger in real time? How do we bring attention, right? I mean, bring attention to the desk user or deskless user. I didn't show the app today, right? So those are happening, right? And though our example is more like dynamic, tons of information. How can I get your attention in real time, right? And actually, there's a paper about using deep fake. So basically, is you get a lot of inputs are different mapping styles, and then you automatically generate styles from those and apply to the map data. And I think there's a paper about it. So, encourage you to read it, right? It's using something called GAIN. So basically it's how to deepfake technology, right? So it's very interesting. For example, AI needs training data. So when you have unique training data, and you can have a better AI. However, it's very difficult with those data. So as a result, there are AI to simulate data as the input for AI. So that's very interesting. And actually, the other thing I wanted to mention about is I have a friend, and then he used a video game called the Grand Theft Auto. I think there's a video game, and then to create a lot of training data set to train their deep learning. So for object detection, I was like, wow, interesting, right? So you can use a simulation engine, right? Very geospatial, and then to create training data sets so that you can identify, automatically detect the real world object. That, for me, that's very interesting.
Very cool. We have 1 or 2 more minutes in the session if anybody wants to put any other questions into the chat. But in the meantime, while I wait to see if I'll just thank you, Steve. That was a really fascinating presentation. So thank you for taking the time to meet with us today and give us your view of the evolution of predictions as we move forward. So thanks very much.
Thank you very much. It's my honor to be here.
Okay.